Hey, I'm David, and I'm going to talk about Syne, which is a new library for large-scale and reproducible hyperparameter optimization. The key features of the library are that we support wide coverage of HPM methods for distributed optimization. In particular, we support multi-fidelity, which allows to stop configuration after seeing only a few bad epochs, transfer learning methods that exploit information on other tasks of previous tuning, and multi-objective that can optimize multiple objectives at once. In addition, with one line of code, one can run in many different environments, such as local machine or cloud machine or simulation, allowing to essentially go smoothly from research to production or large-scale experiments. And in particular, we support out-of-the-box benchmarks for asynchronous methods, where you can simulate for asynchronous optimization from pre-computed evaluation in seconds rather than hours or days with naive approaches. Here's a code snippet showing how to use the library with Bayesian optimization, where 4 configurations are run asynchronously. Let's see in particular what it does for Bayesian optimization. So it runs 4 configurations at the same time, and with Bayesian optimization it gets better and better as the task goes on, but on the other hand, it lets configuration that are pretty bad run fully. Asha, in contrast, stops any configuration that is bound after a few epochs, but sample configuration at random. We also provide support for Mobster, which combine Asha and Bayesian optimization essentially. And finally, we support transfer learning methods that learn from previous tuning. As you can see here, these methods learn from the start which hyperparameters are good and bad, and exploit that after learn from previous tasks. We also support lots of other schedulers. You can check our paper to know more about them or to see the experimental performance comparison. Importantly, we also support changing how trials are executed with one line. For instance, this code snippet shows how to perform tuning on a local machine, but by just changing this line, you can decide to run instead large-scale experiments on separate GPU instances. You can also decide to run on simulation from pre-computed evaluation. The simulations are highly optimized, and they can run this method in seconds with indistinguishable results. So and this also supports like surrogate benchmark, not just tabular benchmarks, where you can just decide on the fly which surrogate you want to put on top of your evaluation. In addition, so the simulations are highly optimized and realistic, and in addition, we have a flexible API for backend where you can easily add new backends such as Slurm or Java. Thanks for watching. Here's the link to try it out on GitHub, and of course, we are happy to get your feedback and your contribution.